All right, so I'm going to go ahead and forward here to our next speaker. And our next speaker is Alan Roble. And he's spoken here before, as you all probably know, but also you may not know that he has a lot of training videos that are out and linked to on our YouTube channel. He's got his own, but we link to them. So he's got some very interesting information to share, and hopefully you'll look that up. Alan? Over to you for a universal work unit scheduler.
Thank you very much, Jessica. I've got my quick poll question here. Forward. Hello? Yes. I suppose this is really confined to people who are using HPCC at the moment. But have you found the need for multi-stage processing on 4? There are work units really working on 4, and but do you find instances where really the entire job can't be done by 1 4 work unit? That'd be interesting to know how extensive the issue is. Anyway, without further ado, I'll just say what problem is being addressed here. Well, there are actually loads of scenarios. In fact, I could have put many more here, but the font was going to get too small. So I've kept it at 4 scenarios where really you need multiple work units to do one job. For example, extraction, transform, load of data. It's almost invariably a multi-stage process. You've got other for example, a watcher work units where you've got one work unit which is actually monitoring the running of another work unit. You've got builds of retro data sets where you're building lots of key files. They're all the same, but basically you're building them for different run dates. Let's say one for every month or one for every quarter. And there's multiple builds there, but the only difference between one build and the next is the run date. I found a rather silly example which I had to do was my boss wanted the process time in the work unit. And of course the work unit itself can't actually generate a report on its own process time, so I had to use a daisy chain of work units in that case. So, but there are many more reasons why you need multiple work units. Anyway, so the concept behind this is that it runs, your job runs as an ETL function, and it's passed effectively something which indicates what the next job is. Actually, it's an unsigned number, and it has to return a next job. So the daisy chain, which is the harness that your work unit runs in, is not only gives the function the next job ID, that the function itself has got control at runtime about what the following function that runs is. As I said in pseudocode, you've got a daisy chain harness that calls your function and the parameter of the next job to run, and really in a nutshell that's it. So it's controlled by a finite state machine or directed graph. And this orchestrator can run in parallel, work units either in parallel or in sequence. So options for returning next job, you can just echo back whatever the scheduler or the harness has given you as the next job to run. So you do your work and then just echo back the next job identifier. You can return 0, which will unconditionally terminate the sequence of work. So that's a way of terminating early or terminating when you've finished the job. Or you can return a completely different job number at runtime that is it is not the default behavior. So that might happen if, for example, if a particular day you've got a particularly large ingest of data, you may want a slightly different sequence of work units to run. So on that case, you might actually return a different job number that would cause the harness to fire off, go down a different route. Just because of the size of that ingest that day, for example. the way it actually works is that your function, obviously the mandatory part of your function is to take a next job identifier and return the next job. And you can always, in ECL, you can always tie an action to return type with the option when. So it says in this construct here, it's returning this next job after performing action, and it is sequence. So this function won't actually return until that action is complete. So you just have to read up when in the reference manual there. So that's how the actual target function executes something, but also just returns a scalar value. This might be a bit small, hopefully people can read it. So how do you define the sequence of work units? Well, each job is defined by a record that contains the work unit name. In other words, where is it going to be identified, how this work unit is going to be identified, and the each string containing the ECL function that's going to be called with placeholders to allow parameter passing there. And you can run, and then if you want to run in parallel, so you want to run sequences of work units as in parallel, then you've just got data sets of those data sets, and effectively we can run any number of queues, sequence of work units in parallel here. So you've got some additional features. Apart from the next job placeholder, you can actually pass a function, a placeholder. You can put a placeholder parameter into your function of parent work unit ID, and that will get replaced by the work unit ID of a parent of this current work unit, and this allows information to be transferred from, or communication to occur from the parent work unit to the child work unit. In fact, I'll show a demo where I actually use parent work unit ID. There's also, you can actually pass, it's a directed graph, or it's a finite state machine, and you can actually pass the finite state machine itself to the target function. I haven't actually found a reason for doing that yet, but you know, the option's there. The conclusions to this, the harness runs, it's truly independent, agnostic to working as any application. In other words, the harness will work as long as you wrap your work up in a function in the way I've just specified. It works. So it's no preconceived. There's no. I've seen some harnesses where they're basically biased towards an application. But this is completely agnostic to any application. There's no limit to its flexibility. It's a finite state machine, so you can do whatever you like with it. For example, I've actually got a unit test where the target work unit actually uses the harness itself to nest work units. So you could end up with nested scheduling of work units. I don't know if anything would do that in reality, but you know, the option's there. And the harness is tied to the work unit itself. It runs in the same said work unit. So if a work unit crashes, the wrapper, the harness is terminated as well. The machine just stops without child work units being left lying around, or without events being descheduled. The whole thing cleans itself up, just because the harness is actually part of the work unit there. I'd like to show, so all this is available, all this has been published in the HPCC community site tips and tricks section. It's called Universal Work Unit Scheduler. So you can find all the code and some demos actually on the HPCC community site. I think I'll share my screen now, and if I can, share screen. Which one? That one. Just got to find the correct screen. Ah, good. Right, you can see it. So this is the universal schedule. It's just a single module, and you have to configure. The only thing you have to, obviously, when you download it from the trips and ticks section, you have to configure 2 or 3 things, but really the only thing you have to configure is the folder that you place this module in. So I've got a folder called Robel, my surname, and I've plonked the Universal Workunit scheduler under that folder. And really, that's the only thing you need to do to configure this. There may be your ESP names and form names may differ, so you may have to configure things other than that. But really, the only thing you'll have to configure is the home folder setting there. And I'll just show a demo here. For example, here I've got 3 queues, so I want 3 work units, sequences of work units to run in parallel. The first queue I want to run 4 work units. The second queue I want to delay the running for 1 minute and then run 2 further work units. And on queue 3 I want to delay, let's say, for 2 minutes, and then I want to run some subsequent work units. And this is just demonstrating that they're macros. You don't actually have to write finite state machine. They're macros that will do it for you. So here, this is the work unit sequence definition has defined the what you want to be done, and then this defined workflow that will create a finite state machine from your work unit definition and places it in attributes finite state machine. The second macro I've got here writes initiator ECL for that finite state machine. So finite state machine in this case is the parameter input to this macro, and then you end up with that will generate in action a load of ECL that will fire off this sequence, and then you just have to submit the work unit, and there's also a submit work unit function inside the scheduler as well, so I can submit the work unit there. Now let's just submit that. I've wound down some of the delays from 1 minute to 2 minutes because I just want don't want to bore people. So if we see what's happened here, so initiating the work units, if you're looking at the top right hand side here, you can see that Q1 is starting, Q2 has been delayed, and Q3 is starting. Let's just run here. So we've now got Q1 started, Q2 and Q3 are running, but they're currently delayed. Notice I've used the placeholder parent work unit ID in the name of the work unit so that you can trace through and you can see what work unit has been spawned from here. So just handy if you use that there. So here we are, we've started, waited too long. Q1, Q2 and Q3 have now started as well. And finally Q3 there we go, and the entire sequence is completed there. So that's one example. I'll do a second. These demos are all on the trips and tips section. This is a non-standard finite state machine. This is where you might want to do retro builds, where you want to do key builds, all for different dates. So I want to do a key build starting on 2006 or June or so in 2017, and I want to do what should we do here? Let's do a load of month builds, so every month, and I'm passing information. This demonstrates passing information from one work unit to another. So this work unit will output named output a build date, which will be picked up by the child work unit, and it can build for that date and then can daisy chain on and return its the next build date to run. Now you have to be careful here because you can get into infinite loops. So for example here, this this current job, next job is 1, but the following job after job 1 is also job 1. So if you're not careful, so it's relying on the target function to terminate, in other words, return 0 at some point. And so yes, you do have to, you can seriously break for, but as I said, you have to be careful to make sure that you do get your termination conditions right, because the finite state machine itself may not terminate. So if I run this one, I'm hoping it's better terminate now after I said that. Let's get rid of those. Just oh, it's not clearing up. So here we are. We've initiated the work unit sequence. So we're now doing a build date of 2007-704, and its child build is running a key build, let's say, with the next build date, and here the next build date. So let's just close those, and you can see from the hierarchy of the identifiers of the work unit IDs that 5530 has been spawned from the previous one here, and here 5534 was spawned from the previous work unit, this work unit here. That's still, well, eventually it has actually completed. So my termination condition worked fine there. So along the same theme, of course, I mentioned about running things in parallel. Well, you could do year retro builds, let's say, in parallel. So I could do some year builds, monthly builds, and day builds, all in parallel. So here, my finite state machine again is really just duplicated up that example, but where I'm giving different increments for building of the keys. So I want a key built on a year basis, on a month basis, on a day basis, and all these builds, let's say, can run in parallel. And but again, it's a non-standard finite state machine, so you can't actually use the macros for this. But anyway, let's just try this and see what's happening here. Right, year build's not showing very much at the moment. So here we are, we're starting, we've got the year builds, the month builds, and the day builds starting already. Actually, the first ones are completed. So the year builds are still going, the day builds are still going. Again, it's doing much the same, just building with different dates, but for the day builds, you'll be incrementing by a particular day. So the next day build is the 6th. And let's just see how long that takes. Let's see what's happening here. Hopefully it don't take too long. So the right, work you completed. So the year builds have completed, and we've still got the month and day builds running now, but the year builds have completed. I'm still running the day, and there shouldn't be too many of those left, hopefully. Right, so that's completed. So the day builds, all the day builds have completed. We've still got a few more month builds to run. This is just demoing again that this finite state, or this harness will actually work with not only sequence work units, but sequence streams of work units. And that ultimately should finish itself. Yeah, so that finally, the month builds have also completed. I'm going to do one last demo, again a different scenario, one that I mentioned at the beginning of my talk, is I want a watching work unit that's watching the state of another work unit, and I've here in the demo, I've just put my email address in here. Again, I'm referencing the harness that I downloaded and put into folder Robel. So we should, let's just see if I do get an alert here. So this is starting off the first task run is task 1, which is the watcher work unit, and that its subsequent job identified is task 2, which runs the actual job, and after task 2, basically we're saying we're terminating. So what's happened here? So the watcher's completed and the run has been successful. So let's just see if I've got. It can take surprisingly long time to get an email up. There it is. Come on. Come on. Oh, there we go. And hopefully you can see that it's fired off, the watcher's fired off an email, successful completion. I've actually got another email there which does exactly the same. I've got another demo where the target work unit actually fails and it sends off, but I think you can take it as read that the email will give a failure, indicate failure, and send success on that point there. So I'll stop my screen share now. Hopefully I can do that. And move on. Oh, that's the next note. Move on. So really the second quick poll question is, do you think this will be applicable to your organisation? Or is this going to be useful to you? We wonder, that'd be interesting to know. I think at that point, I'm passing back to Jessica. Jessica?
All right. Yeah, I'm here. Thank you so much, Alan. That was great. Hopefully people have gotten something out of this. I guess we'll see from your second poll question.
Yes.
All right. So while you take a moment to look at the questions that have come in from the audience and prioritize those, and audience, if you have questions for Alan, this is a great time to submit those. We're going to go ahead and take a quick look at your first poll question, and that was, if using HPCC systems, have you found the need for a multi-stage processing on Thor? 40% have said yes, 10% say no, and 50% say it's not applicable for them. But hopefully, for those who have a need for this, hopefully you've got something that you can apply to your work.
Yes, it was actually a HPCC specific question, really, wasn't it? Yeah. Yeah.
Well, that's okay. This is our community, so I think it's a great question for this one. So, all right. So
okay, questions, hit me. Yeah.
All right, here we go, Alan. All right. Why is this not an HPCC systems bundle?
Yes, in fact, it was originally intended for that. There's a few issues with that. The bundle has unit tests in it. There's a unit test harness with the bundle, and it's got to match exact. There's an XML results, expected results, and when the bundle runs, these smoke tests are run, and your results of your run have to match exactly the expected results in the XML. Well, really, the only expected result from this harness is a work unit ID, which varies all the time. So there's no constant response that you could really check against. So it didn't actually fit in the bundle harness, unfortunately. Eventually, it could be if somehow the unit testing or smoke testing is enhanced in bundles, then perhaps it could move over to there, but at the moment it really doesn't fit into the bundle harness, unfortunately. Okay, next one.
All right, here's our next one, Alan. The question is this a scheduler or a sequencer? Which one of those words best describes the function?
Yeah, I'm rather hoping I wasn't going to answer that question. Yes, it's not a schedule in the sense that, I mean, you can't say at 3 o'clock in the morning, run this task. And really, it's a sequencer. Well, it does more than sequencing. You run stuff in parallel. I've actually thought of a better word for it since then, since I all uploaded it. I think it's really an orchestrator. So it should be called a work unit orchestrator is really a better word for it. But it's there now. It's up there. But yeah, perhaps it could have been worded better. So really, a better word for it is orchestrator, I think.
Well, it's still, I think, it's an extremely useful tool. So if we go back to your last poll question, the question was, do you think this will be applicable to your organization? And 100% of the people that voted said yes. So hopefully.
Well, I found it useful. It's been very useful inside LexisNexis, I tell you.
I definitely, I think it looks to me anyway, like it would be very helpful. So thank you so much for taking the time to share that with us.
Thank you for giving me the time. It's been great fun.